So you learned about translations back in Math 20, okay, with quadratics, and we talked about stretching a parabola vertically. Didn't talk a lot about horizontal stretches because with a parabola, a horizontal stretch can be a vertical as well. You can get the same result. We're going to look at that more in detail now. We did reflections, opening up or down. We did translations. Where's the vertex? Okay. So now we're going to look at translations just in general. The odd time of graphs like what we know, but basically kind of going to keep it a lot of this in general case. So in terms of f of x, right? Some function f, some function g, that kind of thing. And as we go through all the units, we're going to that's almost the first thing we do in each of the following units. Sinusoidals, exponentials, logarithms, radical functions, rational functions, all of that stuff. So just a reminder there, some terminology. Translation is a slide transformation. Okay? Think of a slide when you go to the park, right? You're at the top. You're still the same person when you get to the bottom, unless something really bad happens. And so you've changed your location, horizontally and vertically. So a translation can be horizontal or vertical or both. So it's a shift of a graph without changing its shape or orientation. Image point, that's the point that is the result of a transformation. So you start with a certain point, you do a transformation, the image point is where you end up, okay, where that point ends up. Transformation, so sometimes students get mixed up with the words. This is sort of the big title of the whole unit, right? That encompasses translations, that's horizontal and vertical, stretches and reflections.
Is stretch like the correct mathematical term?
Yeah, but you have to have already vertical stretch by factor of blah, blah, blah.
Okay.
Yeah. Mapping, that's the relating of one set of points to another, so that each point in the original set corresponds to exactly one in the image set. You use a coordinate form, an arrow, new coordinate form. Okay, that's a mapping notation. Okay, so remember, throughout this unit, you'll be working with two types of equations. We talked about this before in terms of f of x, or maybe g of x, whatever the label is. Okay, or if we actually know what the original function is, then you'll have that original function in it. You'll have the squared, or the absolute value, or the radical. That then we could actually graph on our calculator. Okay? The other way, we would have to be given what it looks like on graph paper in order to do any transformations. Okay, so let's compare what happens. And you might get the sort of the gist of this pretty quickly, but we're going step by step here. Okay? So it says on the same calculator screen, graph goes through. So you can do that now. Okay, just do a standard screen. We did talk about cubics a little bit last year, so you should know this. Shape. If you take a look at them, they all look the same size. Okay? Same sort of direction of path, going from quadrant 3 to quadrant 1. Okay? But that point of inflection, where it changes from opening down to opening up, has moved. Okay? So So looking at this, if you didn't see the scale, okay, then you know that this is the y equals x cubed. You might think that this one is the y equals x minus 2 cubed, because these are negatives down here, right? Well, let's trace on it. So trace will go to the first. If I cursor down, it'll go to my y2. Notice how that's on the right-hand one. Then you have an x minus a number in the bracket. Just think about it in parabolas. When we had x minus 2 all squared, plus whatever, plus 10, let's say, our vertex was at positive 2. It's whatever makes this equal to 0. That's your x value, right? Because we're looking at the x-axis. So how do we get a y value 0? That has to be the opposite sign. So anytime you see x replaced with x minus 2 or x minus any number, it's going to the right. So that is my x minus 2 cubed. So this was, use this, x plus 4 cubed. So that's going to be the one on the left. So again, if I cursor it down to my next graph, you actually can't see, it's too far up high because it's down the y-intercept, but you can trace along there so you can see the cursor if you want. There you go. That's the x plus 4 cubed. Okay? So do not get mixed up. That's the most common mistake. Sometimes on the diploma exam, the first question is something about horizontal translation. Okay? Don't get it mixed up. If it's x plus something in brackets, you're moving left. X minus something, you're moving right. Okay, so when x here is replaced with x minus 2, the graph of the new graph is the original translated. Remember, we said right. Oh, sorry, I gotta put the number of units here just by this word. 2 units to the right. If you're writing it yourself, you can actually say move to the right. Okay. Now, point 327 is on the original. The image point of it, okay? You don't put 3 in here and find the y value. That's not the image. It's performing the transformations on this. So if I am doing this, I'm moving right 2 on every single point here. So that would become a 5. So this is going to be 5, and the y value will stay the same. You can check that it works. Now put 5 in here. 5 minus 2 is 3. 3 cubed is 27. Okay? Mapping notation, that's basically in general. So you're starting with any point x, y. What happens? You're moving to the right. So you're adding 2 to x. Your y value is staying the same. So mapping notation, I say it is what it is. Okay? If you look at mapping notation, that's what you're doing. You're adding 2. You're going to the right 2. Function notation, or in terms of x, you do the opposite of what it looks like. So if it's x minus 2, you're going to the right 2. Whatever makes that bracket equal to 0. So then this one, remember this was to the left, so translated 4 units to the left. Okay. Point 327 lies on the original, so what's the image? So we're going 4 units to the left. 3 minus 4 is negative 1. And you can check it. Negative 1 plus 4 is 3, cubed is 27. 4 to the left, we take our original x value and we subtract 4 from it. And we keep our y the same. Okay. So that's horizontal translation. Let's look at vertical translations. So take a look at this here, right? So that's your original function, and now you're given this, okay? We're trying to compare it. Notice how now we've replaced y with y minus k. We don't often show y with other terms on the left. Sometimes we will in this topic, in this unit that we're looking at. This is considered transformation form, okay? Oftentimes, though, we'll say solve for y. So when you solve that for y, you will get y equals f of x plus k. Right? So there will be different forms to solve. In any case, you have your base graph in there. Now let's delete the other ones that you had, or clear them, I should say, and then enter these new ones. So to enter these new ones, how do we do that? Okay, well, we're going to have to solve for y here. Oh. Come on. There we go. All right. There's the original. There's one up and one down. Okay? So, if I go trace, it goes to my y1. If I go to my y2, that's where it's x cubed plus 2. It's up here. That makes sense to me, right? We're adding 2. Well, that makes sense because you're taking your original y value for x cubed and you're adding 2 to it. When it's in this form, okay, it's just like the horizontal translation. We replace y with y minus 2, so we're going up 2, opposite side. The nice thing about vertical translations, if you solve for y, that constant term tells you exactly what to do. If it's adding, you're going up. If it's subtracting, you're going down. Okay? And then if I go to my y3, it's down here, subtract 1. Okay? So oftentimes, even if it's given in the transformation form, you might rearrange it to help yourself. So that's going to be translated 2 units up. And then this original point, if I'm going 2 units up, my x value stays the same, but my y value increases. And you can figure that out. Put 3 in, you get 27. Bring the 2 over, you get 29. Mapping notation, the x value stays the same, and then we add 2 to the y value. Okay. Replacing with y plus 4, so that's 4 units down. Okay, so the original point lies on the graph of y equals x cubed. So now, if we're going 4 units down, we go 27 minus 4. So our x value stays the same, and we subtract 4 from our y. So notice, that is y plus 4, that's y minus 4. Okay, notice the difference. Again, if it's shown in this transformation form, because transformations mean you're basically taking your original x and replacing it with x plus something, or x times something, or the opposite sign of x, or you're replacing y. All right, but it's just nice with y is that you can bring that term over to separate term. and vertical, and now summing them up together. So if you have y equals f of x, and x is replaced with x minus h, then the new graph is the original translated h units. Well, depends what h is, right? So it will be h units to the right or left. But what is it going to be? How do you tell? So here, I'm going to go. If h is positive, so greater than 0, then write absolute value of h. Oh, actually, if it's part of it, you don't need absolute value, right? Okay. Because, an example, if h was 3, this would be f of x minus 3. So what we've just learned is that goes to the right. If h is less than 0, then we're going to go left, and that's where we need the absolute value. Okay, because a negative in here, let's say we have -2. So we're going to go x minus -2, which is f of x plus 2. So what we just learned is if we replace x with x plus a number, we move left. Okay? So then, the original point xy, if we're making this transformation, then we're going to, so in this case, we don't know what h is, but we're going to do the opposite of what that is. So this is going to be x plus h, and y will stay the same. So if h was positive, that makes sense, we'll be adding that. If h was negative, then that would be a plus there, so you'd be subtracting, but when you add a negative, you get subtracted. So it only works out. Okay? Okay, then with the vertical, you try to see if you can summarize it in a similar fashion. Okay, so take an example. If k was 5, it would be y minus 5 equals f of x. Bring that 5 over, it would be plus 5, so you're going up 5 units. If k was negative, say -3, this would be y minus -3, which would be a plus there, which means you're going down from what we've learned. Okay, and we're going down how many units? We're going down 3, which is the absolute value of what k is. Going down basically takes care of the negative, right? Okay, and so then here, vertical x, and then your original y plus k. If k is positive, yeah, you're going up. If k is negative, you would end up being out of the negative. Okay, so just a reminder here about this word. We've heard it before. That's really a geometry word for equal. It uses the same shape, same size, same shape. In geometry, two congruent triangles are exactly the same triangle. Same size, same angles. In a graph, they're the same exact shape, same mins, maxes, slopes, all that kind of stuff, just in a different location. Okay, so let's practice some of these. To translate a graph of y equals x up 5 units, you replace y with y minus 5. If you're just replacing y, it's the opposite sign there. So then the new equation will be y equals, y minus 5 equals f of x. Because we're replacing, right, this with this. And then there's an or here because, as I said, most times we solve for x. So bring that constant term to the right. In the first one, we didn't know what our original graph was. Just f of x. The next one, we know it's a radical function. Okay, we're translating it to the left 3 units. So we want to always replace the original x with what? If we're going to the left 3 units, then we've got to replace with x plus 3. So our new equation would be the root of x plus 3. All right, this one is a parabola. It's already been transformed from the base parabola of y equals x squared. Now we're going to take that and do some more to it, translations in this case. So we're going to translate this, right 5 units and down 8. Okay, so we want to replace x. If we're doing x, that means it's a horizontal translation. So that's right 5 units. We will replace with x minus 5. And y would be the down or up, in this case down 8. So we would replace with y plus 8. Okay. So, going to just do those replacements, and then I'm going to solve for y. So basically this is like showing you work for this kind of transformation. So it's going to be y plus 8 equals negative 3. Notice how I'm replacing just x. So now I'm going to need brackets where the x was. Okay, and then the x minus 5, maybe I'll do those in red. So I replaced y with y plus 8 and x with x minus 5. Okay. And then also can be expressed, notice how it's y equals. So that just means here, you want to get y by itself, so that means you want to subtract 8. So subtracting 8 will give you minus 6 then. We're not going to expand it out, it doesn't ask you. Okay. Alright, next thing is to actually do some graphing. So there's a absolute value function shown there. That's just y equals absolute value of x. And now we're going to graph that using translation. So you want to take a look at it. If you want to write down what translation, we're going to always use words on a test. But for short form, you might want us to abbreviate. So a horizontal translation, I would use HT. Vertical, I'd use BT. Okay, so horizontal translation, 3 right. Vertical translation, 1 left. Okay, opposite sign there, and because it's solved for y, that is what the translation is. Okay, I would, for translation, do this, both translations in the same step for each point. Okay, so So that means always start with important points like a vertex or any intercepts. And then make sure you've got, a few other points as well. So vertex here to the right 3 and up 1. That's going to be my new vertex. Okay, then choose another point. Now, if I choose this one, I will run out of graph paper just on this, right? So maybe I'll choose this. I'm going to go right 3, up 1. Okay. If I choose this one here, to the right 3, up 1. Please bring a ruler to class. If you don't have a ruler and you have a calculator that uses actual batteries, which is now kind of old school, but still good. Here's mine. What do I do with my calculator? Maybe it's in my office. Anyway, here's an example. This is a straight edge. Okay? Not the side of your calculator, that's too hard. This is a straight edge. If you have a calculator that uses actual batteries. You're not going to have to measure anything, so. Okay, now if you want to verify with your calculator, remember absolute value, you're working it out. So it depends on the calculator. Newer calculators, the ones that can do an exponent, will actually show you the absolute value symbol. Older versions, it will be ABS. So I was saying you're working it out. So, math, cursor writes it num, ABS, okay? Newer versions actually show it like that. X minus 3, cursor out, plus 1. Okay. Absolute value function is very similar to a parabola. Okay, what's in the absolute value helps you get the x value at the vertex. What's out of it gets you the y value at the vertex. Okay. So the vertex there is 3, 1. Okay. So this says, complete the following for the given functions whose equations are expressed in terms of x, so we actually know what they look like. So, first, original function, 4 over x. Next one, 4 over x minus 5. So what's changed? There's still a 4 in the numerator. Denominator, instead of x, is x minus 5. So it's like x has been replaced with x minus 5. So that is a horizontal translation. So, pretty limited in space here, so you could use the abbreviation, okay, and 5 right. Right, so if it helps to put brackets around any expression with x, do that. That kind of reminds you, replace x with x minus 5. Point on the original function, image point, so that means you want to add 5 to the x, so that's going to be 6, 4. Okay, test it out, put 6 into your image function. 6 minus 5 is 1, 4 divided by 1 is 4. Okay. Original function, y equals 2x cubed. Okay, so that's now our original. It's not the base graph. This is the original. How does that compare to this? Well, y has been replaced with y minus 6, so there's a vertical translation. There's already a 2 in both. Okay, so that's nothing's changed there. And now instead of x, there's x plus 4. So there's both a vertical and a horizontal. Doesn't matter which order you put them in. So horizontal is 4 left. Vertical is 6 up. Now, I'm only using that abbreviation because it's space constrained. On the test, we say horizontal translation 4 left, or left 4, or left 4 units, whatever. Just make those into words. So here, if I'm going 4 left, I'm going to subtract 4, and 6 up, I'm going to add 6. So that's going to be negative 6, negative 10. And you can check it out. Negative 6 in here, plus 4 is negative 2. Negative 2 cubed is negative 8, times 2 is negative 16. I put negative 10 in here, subtract 6, I get negative 16. Okay. Now, look at this one. We don't have what the new function is, but we're told what the image point is of 8, negative 1. So, going from here to here, what would my work be like I did here? Well, I'd have to subtract 3 to get 5, and what? I'd have to subtract 1 to get negative 2. Okay? So that means if I had to subtract 3 from this, that means I went 3 left. If I had to subtract 1 from this, that means I went 1 down. Okay. So now I want to replace my x and my y. So y, vertical 1 down would be y plus 1. You can put brackets, you substitute them in if you want. Okay. The 2 has to stay. You are replacing only the x. So put brackets there. 3 left would be x plus 3. And then outside of that, you just copy out the minus 5. Okay. If you don't put the brackets there, you just got that wrong. Okay. If you want to solve for y, it doesn't ask you to, but if you want to solve for y, then it would be y equals. You could expand that out as well. We'll talk more about that. But bringing that over would be minus 6. Okay. So or not right now.
Though if it was on a test, they tell us what form.
Okay, so turn over the page. So just so you know, a prime symbol, which is like sort of an apostrophe symbol, next to apostrophe if you're like typing, like straight, not curved. It represents the image. So this just means when you see A prime, that is the image of A. Okay? B prime is the image of B, C prime is the image of C. We also use that prime symbol in calculus.
And in probability.
And in probability. Yeah. So, gotta know the context of your question, right? So, graph of F has been translated to obtain the graph of G. That's why the sign symbols are on G there. Describe the translations applied. And so you basically choose, because they're labeled, choose one of them and see what's happened to B, to get to B prime. So here, you're going from -4 to +4. So that is 8 to the right, and then up 2. Okay. So horizontal, I have a bit of space here, so I'm going to write it. So horizontal translation, 8 units right. Vertical translation, 2 units up. Okay. So write it in this form. Okay. So you can go right to that form. So our new graph is called g of x. It's labeled G. What did we do to the original? So we translated horizontally 8 right. So that would be x minus 8. And then we went 2 up, which would be over here, y minus 2. When we bring it over, remember, it looks just like it is. So if we're going up 2, then that's plus 2. Okay, so you can just put it in right away. Okay, so now we're going to do some graphing again ourselves. So you've got a base graph given there on the grade paper, and you have to use the chart. You're going to find all those descriptions, image point, domain, and range. Graph as well. You might want to graph first before you fill it in. Totally up to you. I'm going to minimize my screen a little bit here. Or actually, I think I'm going to dual page it. Yes. It doesn't matter. Okay, so you just have to be aware of both. If it does matter, we'll tell you to use these other notations. Okay, so you've got y equals f of x. That's this graph. Obviously, there's no transformations. That is your base graph. Domain of that. So look at your leftmost point, to your right. So that's 7. Oh, actually, we don't need that right now. So I'm thinking ahead. So that is your domain from -5 to 2. Because of the space in here, maybe it is easier to do that interval notation. So domain would be -7 to 2. Just because it's not a whole lot of space to write it in Oh, -5 to 2, sorry. It's 7 units, yeah. Okay. Then range is this. So from -2 to +3. Okay, so first one, replacing y with y minus 4. So because that's in transformation form, it's the opposite sign. That means you're going up 4. If you want, you can rearrange this. Okay, so you're going to go up 4. So my recommendation, do all important points and do them in order. If there's lots and you're not, it's okay for translations, you know what the shape is going to be. When you get to stretches, it's a little bit harder to know what the shape is going to be. So here, if I go every point up 4, that would be the first one. That'll be the second one. Join it up as I go. So it'll be the third one. Okay, now, I'm not using a ruler because it takes a long time. But use a straight edge. Mistake. It's harder for me to do that. Okay? So that was vertical translation for cup. So image point of xy would be x and y plus 4. Does the domain change when you do a vertical translation? No. So this would stay the same. Now the range 4 gets added to every original x value. So you can look at the graph, or you could add 4 to each of these, right? So that should be 2, 7 if you were using interval notation, or if you were using set builder, you'd add 4 to both. And then just take a look. Yep, 2 to 7. Next one, we're given the image. We got to look backwards to fill in the equation, etc. So our original x, now we're subtracting 3 from it. So that means we're going left on the number line. So that's going to be a horizontal translation, 3 left. Okay, because mapping notation is what it is. Nothing done to y. So in our new graph, that would be f of x plus 3. We're going left. We're going left, actually we'll do this in green. So here, left 3, left 3, left 3, that wasn't so straight. That's very bad. So now our domain has changed because we're doing a horizontal translation. 3 left means we're going to subtract 3 from both of these, so that'll be negative 8, negative 1. You can check it out, negative 8 to negative 1. And our range will stay as the original range. So go back to the first one. Domain and range given, it's in that builder notation, so that's okay. So you want to compare that to your original. Okay. So how do I go from negative 5 to negative 7? I would subtract 2. Make sure it corresponds, because once we get more than one transformation, there might be stretches in there as well. So here, go left 2, that works for that. So horizontal translation to left. Here, starting at negative 2, now this is at negative 6, so that would be going down 4. Does that correspond to that? Yeah, it does. So vertical translation 4 down. Okay. So y replaced with y plus 4. X replaced with x plus 2. And then it says actually to leave it in that form. So I'm not going to solve for y. Okay, so I need the y and the constant term on the left hand. Mapping, left 2 would be x minus 2, down 4 would be y minus 4. Okay, we were kind of lazy here and didn't put the full words in. We just said write 6. We'll go back to, oh, I didn't graph that. Oh, we're not in there. I erased something. Which one did I erase? So that's the original. That was the
This one, I want to take this and go down 4 and go left 2. Okay, so right 6 down 1. Okay, so that would be y plus 1 equals f of x minus 6. So original x add 6 to it, original y subtract 1 from it. Original domain, we're going to go right 6, so add 6 would be positive 1 to 8. Okay, range down 1 would be negative 3 to 2. Okay, so let's do down 1 to the right 6. This one I think is out of space a little bit. Oh no, make it this way. Okay. Always get into the habit of checking, right? Your domain, your shape hasn't changed. So how wide is your graph is the difference between these. 7 units. 7 units. Okay, so you didn't change anything. The difference in the y's is 5 units, so is this. Right? If it changes, that means there's a stretch, and we haven't even talked about stretches yet.
It's like a bunch of like binding stripes running across the finish line.
Yeah, it does sense, right? And actually, yeah, it does. Did you watch the Olympics this summer?
Yeah.
So when they did the photo finish,
So weird.
and they were going like this, or I don't know, their head, they're kind of going their chest. Yeah, it does look like that. Okay, so you just maximize this. Okay, next type of question. So we're trying to give you a variety of types of questions that you might see on a test, that you might see on a diploma exam. Okay? So the graph of y equals f of x is transformed, gives you the mapping notation. Write the equation in that form. So with the constant with y on the left. If you give it to me the other way, you're not going to get full marks. Right? So you have to read the question. Okay, so if you want to write it out, you can quickly. So, yeah, I'll do purple. Horizontal translation, 4 right, based on that mapping. And vertical translation, 1 down. So this is going to be y plus 1 equals f of x minus 4. So that has a plus, that has a minus. That has a minus, that has a plus. Okay, next one, domain in interval notation and range. State the domain and range for the transform function. So what's happening here? You're going up 3 and to the left 5. So you can just write that down if you need to. So vertical translation, 3 up. Horizontal translation, 5 left. Who is talking? Yep. Okay, so the new domain Original, now we're going 5 left, so we need to subtract 5 from both of those, right? Because that's not a point, that is the domain, right? So everything has to translate. So -6 to +3. And again, that's 9 units, and this is 9 units, right? So you haven't changed, you just changed the location of it. And then range, 3, 7, now we're going, oh, what did I just do? What did I do wrong? Oh, no, I didn't. Oh, okay. I just had these in a different order, so these match up. And these match up. Sorry. I'm all good. Range, 3 up, so that's going to be 6 to 10. Okay, again, difference between these is 4, difference between those is 4. So you haven't changed the shape of it. Okay, next one is telling you your new, new domain and range from that original, right? This is still in question 7, still with that g of x defined, okay? And we want the new equation. So compare. Notice the difference here, that's still 9 units, so it's a translation of that. So how do we get from -1 to 4? We must have added 5. Does that work for the 8? 8 plus 5 is 13. It does. Okay, so there was a horizontal translation, 5 right. Okay. Then from 3, 7, how did we get to 0, 4? Well, 3 had to go down to 0, so that means it went down 3. Same with the 7. So 3 down vertically. All right. That was our original function. We're not using x in this one. It's called y to g of x. So now I'm going to replace y with y plus 3 and x with x minus 5. Not going to use f because this wasn't called f. Sometimes you'll be asked to name your image function another, like maybe call it h of x, and solve for it. So then you would replace that y there with h of x, but we're not asked that in this question. And do that more when you provide all the transformations. Okay. So domain and range of that function are given to you. We want now the domain and range of the original. Okay. So what happened to this to get this? So that would be a horizontal translation, 2 right. Vertical translation, 4 down. To go from this to this. And that's your domain of that image graph, right? So we want the original. And give it, if that's given in Set Builder, we should give it in Set Builder now. What's missing in those squiggly brackets? Yeah. So why is it missing? Because a couple years ago, the Alberta diploma exams, we didn't really care too much about whether the X element of set of zeros was in that form or not, in the domain and range. Part of the reason was there wasn't actually written response on the diploma, but then it was written and we still didn't care. Basically, it's kind of the default setting. If you don't show it, we assume it's all real numbers, but really we need to show it to show best form. We didn't do that yet. Okay? So just be aware of that. So, original, domain, the original. Okay, so this is our new range after having gone right 2 units. So we got to go back 2 units. So this is going to be 3, less than or equal to 3. Because we take this, go right 2 units, and then we get this. Alright, so the domain and range that are given there are of the final. We're trying to go back to the original. Here, y greater than or equal to negative 6, that was after going down 4 units. So now we've got to go back up 4, so that's going to be y less than or equal to negative 2. And then we're going down 4 units from here, we get to negative 6. You can always check, right? We do the transformations. Okay? Questions like these that we're doing right now are really common. You're not going to, on the diploma exam, going to be asked to graph very much. Maybe there'll be one that you have to graph by hand, one type of question, but not that many. If there is, they'll give you grid paper, it will be there for you to use, okay? So just be aware of that. Most of them are something like this, where you have to figure out what happened. Or not even graph. So here, just be aware of which is which. Sometimes that's a mistake. Students don't pay good attention to detail. What graph is your original? What graph is your image? So it says, given the equation and graph of a function, it's a thin line. So this function here is this one. Okay, this thin line. And the graph of the translated function, the thick one, write an equation of the translated function in terms of x. Then you can verify. So, I'm actually going to minimize just a little bit so I can get the whole chart while I do this. Okay, so the original here, this is the same shape, but it's moved up 3. So that's a vertical translation, up 3. Okay, so what's our equation, folks? We're almost done. So my original is this. I'm going up 3, so I'm going to replace y with y minus 3. Okay. And it says, it doesn't say what form to leave it in, transformation or not. Usually when it is given as function, that's something that you can graph, usually we ask you to solve for y, so that you can put it in your calculator and check it if you wanted to. Okay? Which it does say to do that at the end. We'll do that afterwards. I'll leave that for you to do. Okay, so this is the equation of your thin line here, the parabola. This is our image. Notice the shape is the same. Okay, so I'm going to compare these vertices. So what am I doing here? I'm going left 3, and then up 1, 2, 3, 4. Okay, so horizontal translation, 3 left, vertical translation, 4 up. So then I'm going to go y minus 4 equals, this is where you need to be careful. You're going to replace just the x with x plus 3, I should say. We're going left, minus 1. So I've changed those round brackets to square brackets. for now until I simplify inside there. Now, yeah, you could do that all in your head in one step. But again, when you get to stretches, you're going to want to be really careful of what you do in there. So now I'll go back to round brackets. 3 minus 1 is 2. Okay, and then bring the 4 over. This will be a plus 1. And think about, back to math 20, what's the vertex? -2, +1. Alright? What's the stretch factor 1? So, did you have to use transformations to get that? No. Okay, because we already did quadratics, but maybe for other graphs, you wouldn't be able to tell us easily. Okay, thin graph to thick graph, down 1, and then to the right 2. So horizontal translation 2 right, vertical translation 1 down. Okay, so that one was y equals absolute value of 2x. So 1 down will be y plus 1 equals absolute value of 2 bracket x minus 2. Need the bracket. If you go 2x minus 2, that's wrong. It's different. Okay? You have to replace the x and put brackets. Now, so for y, you can expand out now inside the brackets if you like. Okay. And you can check it out like here. 2 into x gives you 0 minus 1 is -1. You can check this. Okay, so that's a really good sampling of all the translations. So, we get wise time today, so you have until 9 minutes after. So you have basically almost a half an hour. So good opportunity to do some practice. Keep the noise levels down. One person at a time. Why did you go at once? That's my question. You're big people now. You're not in grade 10 anymore.